Welcome back, my lovely subscriber. This is your girl EsthyTech, and welcome to our CKA exam series. But before we proceed, I just want to apologize and let you all know that I've been looking at your comments. Thank you all for watching. Anyway, the reason I've not uploaded all the videos yet is because I'm having flu and can't speak. So that's why I haven't recorded video yet. But I'm going to struggle to get the material out there so some of you guys can have it and prepare for your exam. Because a lot of you are telling me you need me to upload all the videos because your exams or your certification exam is quite approaching. We are now on CKA question 13, and this is one of the most important real DevOps resource management questions in the entire exam. The question read as a WordPress application with three replicas in the relative font namespace consists of CPU and memory. Adjust all pod resource requests as follows. Divide node resources evenly across all three pods. Give each pod a fair share of CPU and memory. Add enough overhead to keep the node stable. Use the exact same requests for both containers and init containers. You are not required to change any resource limits. It may help to temporarily scale the WordPress deployment to 0 replicas while updating the resource request. After updates, confirm. WordPress keeps 3 replicas. All pods are running and ready. We are working with a WordPress deployment running 3 replicas in the relative font namespace. Our task is to divide the node CPU and memory evenly across all 3 pods. Add a small overhead to keep the node stable. Use the exact same resource requests for both containers and init containers, and we are not required to modify resource limits. I'll show you how to do all the math using one-line echo commands, exactly the way you can do it fast in the CKA exam. Let's explain some basic concepts about what the exam is testing. This question is testing 4 core Kubernetes skills. 1. How to read allocatable node resources. 2. How to calculate CPU in millicores. 3. How to calculate memory in megabytes. 4. How to safely modify a deployment using the dump, edit, apply method. The WordPress app has 3 replicas, so we must fairly divide the node's total resources across 3 pods and then add a 20% safety overhead. So now let's spin up our own environment with our helper script, just like I'm doing in this tutorial. Now, let's confirm the real allocatable values with the following command. kubectl get nodes to check the node. Then the describe command with this command kubectl describe node grep minus a 5 allocatable. So you will see this node has one CPU core, 1,846,652 kibibytes of memory. But in my exam, CPU was 4 and I can't remember the value of the memory. But whatever the case, the steps remain the same. Now let's calculate the fair share per pod using only echo, and we'll convert the final memory to MI. In Kubernetes, CPU is best calculated in millicores. One CPU equals 1000 millicores. So we run echo 1000 divided by 3, and the output will be this. And this will be the final CPU request per pod. Now we divide the total memory by 3 pods, convert from kibibytes to mebibytes, and multiply by 120% to add a 20% safety overhead, all in one echo command. So we run echo 1846652 divided by 3 divided by 1024 times 120 divided by 100. And the output will be this. We just round it up to this 700, and this will be the final memory request per pod. All right, now that we have our resource request, let's start with the question. Instead of editing a live deployment, we always use the save exam method. That is, dump the deployment YAML to a file. But before we start, let's temporarily scale WordPress deployments to 0 replicas with this command. Then verify it was successfully scaled down with this command, and you can see the results from the output. Now let's dump the deployment YAML to this file with this command: kubectl -n relative -phone get deploy WordPress -o YAML. Redirect it to this file. Let's edit the YAML safely by VI to the dump file. Under every container and every init container, add the resource block. You must apply to all containers and all init containers. The question specifically says the values must be the same everywhere. We are going to add the resources block, and inside it, we define both requests and limits. To understand where requests and limits belong, you should always refer to the Kubernetes documentation on resource management/resource allocation. Once you check the documentation, you'll see the structure of the resources block and how it is defined under a container spec. In the CKA exam, the resources block is often already provided. That means you don't need to create it from scratch. Most of the time, the request and limit sections already exist, and your task is simply to edit them by adding or adjusting the CPU and memory values. In my local lab environment, this block may not be present, which is why I'm explicitly adding both the request and limits blocks myself to control resource usage. However, in the exam environment, you must work with what is already given and respect the defined limits. The key rule to remember is this: your resource requests must never be greater than the limits. Anytime you calculate or modify resources, always ensure that the request is less than the limit. That's critical for both correctness and passing the exam. Save and exit, then apply the updated deployment. With kubectl, apply -f command. Scale back the deployment to 3 replicas. Final steps. Verify with this command: kubectl -n relative -1 describe pod grep -a 5 requests, and you should see your requests rightly allocated. Confirm 3 pods are running. All pods are ready. No pending, no crash loop back off. But in our working environment here in Killer Coda, it wouldn't reflect the result we require. But this will work in the exam environment if you follow the steps and the rules correctly. And that officially completes CKA question 13. Using real node values, pure one-line echo math, and the safe exam method. Today you learned how to convert CPU cores to millicores, convert memory to megabytes, add a realistic 20% overhead, apply identical requests to containers and init containers, safely update a live deployment using dump, edit, apply. This is real-world Kubernetes capacity planning and a guaranteed scoring topic in the CKA exam. Next up is question 14, where we restore MariaDB using a retained persistent volume. If you want to practice these CKA questions exactly the way I'm doing them in this video series, fast, clean, and exam ready, I've packaged everything for you into one complete zip bundle. Inside the file, you will get all the resources I used throughout this training, fully organized and ready to deploy into any Kubernetes environment. This bundle saves you hours of setup time and lets you focus only on mastering the hands-on exam tasks. Here's exactly what you'll receive when you download it. All 18 CKA scenario YAMLs, full scenario setup script, README for all 18 questions, detailed guide, individual README files, Q1 to Q18, optional add-on, full ingress gateway API migration files, exam PDF, references, your complete CKA scenario practice guidebook, docx plus PDF. Bonus, Google Doc index file. Who this bundle is for: CKA candidates preparing for exam day, students practicing on Killer Coda, Minikube, or Kind, engineers who want clean Kubernetes lab scenarios, anyone building their own hands-on DevOps portfolio, content creators teaching CKA concepts. Why you should get the bundle? Instead of wasting hours creating YAML files or rebuilding scenarios from scratch, you get everything pre-configured and ready to deploy. This is the exact same setup I use in my videos, the same files I demonstrate with, and the same structure that helped me pass the exam confidently. If you want to follow along one-to-one and practice with zero frustration, this bundle is made for you. You can download the full zip bundle directly from my website. Your support helps me continue creating these tutorials, labs, and exam guides so we can all grow together in this DevOps journey. Start practicing like a real CKA candidate. Get the full setup now and follow along with the next questions.
Build the future.
One line of code, one dream at a time. From the cloud to the console, the rhythm flows. In the race.